Hello, students, and welcome to Unit 2. Today we begin our notes on Unit 2. Unit 2 is a continuation of Unit 1. In Unit 2, we will once again look at matter and the classification of matter. We know that matter is anything that has mass and a volume to it. In other words, it is anything that is actually there. And in Unit 1, we learned that matter can be classified as pure. Pure means only one thing is present. And we spent most of Unit 1 on this portion of looking at matter. We spent most of our time looking at pure matter. We defined elements, we defined compounds, and we went into all the terminology related to elements and compounds. In Unit 2, we say this is a continuation of our introduction to chemistry because we are still looking at matter. Chemistry studies matter, the changes matter undergoes, and the energy changes that accompany changes to matter. So in Unit 2, we're going to continue looking at matter, except now we're going to focus on this half. We're going to take a much closer look at mixtures. We know that mixtures are anytime we put two or more substances together and they are not joined chemically. So mixtures, we have two or more things there. On this side, if it's pure, we only have one thing there. Pure can be a compound. If we only have one compound there, it's pure. So table salt has sodium that has reacted with chlorine to form sodium chloride. It is a salt. But if we pour salt on the table, sodium chloride salt on the table, and we only have one salt there, it's pure. Pure can also mean one element is there. But mixtures mean we have two or more things placed together, and they are not joined chemically. So in Unit 2, we're going to spend time on this half. We're going to classify mixtures according to whether they are homogeneous, also pronounced homogeneous, or heterogeneous, also pronounced heterogeneous. So we will talk about mixtures. We'll also expand our discussion of matter, as we'll look in the fact that you can classify matter according to the state it is in: solid, liquid, gas, plasma. And we'll discuss the energy changes that are necessary in order for matter to change states. And we will also look at chemical reactions and how energy changes are evidence of chemical reactions. Energy changes accompany chemical reactions. So Unit 2 is a continuation of Unit 1. We'll build upon what we talked about in Unit 1, and we're going to move into this half starting today. Today's notes are focusing on classifying mixtures according to whether they are homogeneous or homogeneous, or heterogeneous, heterogeneous. So that's where we're heading today. In the notes, we'll also take a look at ways to separate mixtures. So our notes today, we will be working on our 2.3 handout, which is attached in Google Classroom. You can print this handout out if you have a printer at home, and you can write on the handout then, add things to it, or you can highlight it as we go. It's also recommended for many students that you write your own notes as we go and then combine those. The real reason I like students to print out the notes is because when you print out the notes, then you have a hard copy there and you can continue with your organizational skills. So far in your binder, you probably have handouts from Unit 1. Well, today we begin Unit 2. So it would be really smart to have a divider to separate Unit 1 from Unit 2. The first page in your Unit 2 section of your binder would be 2.1. Section 2 or handout 2.1 is your table of contents for Unit 2. It has lists of all the items that you'll receive on Google Classroom for Unit 2, and it also has how many points each of those assignments is worth. Likewise, you could print out 2.2, which is the advanced planner for Unit 2, telling you what we are doing each day as we see it right now in Unit 2. So it is a syllabus for everything we're going. So 2.1 is your table of contents. 2.2 is your advanced planner telling you everything that we believe will take place and transpire in Unit 2. And then this is our first set of notes for Unit 2. So let's go ahead and dive in. Once again, what are mixtures? Mixtures are blends of two or more substances placed together, and they do not join chemically. If you put two substances together and they join chemically, you would end up with one substance. You would no longer have two substances there. So mixtures do not involve chemical reactions whatsoever. When you make mixtures, you would not see evidence of chemical reactions happening, such as smoke, light. You would not see necessarily feel you would not see evidence of chemical reaction or bubbling, fizzing, like producing a gas. You would not see the formation of a solid precipitate, where you put two solutions together and they react chemically, producing an insoluble solid. Those are things you would not see when you make mixtures. You wouldn't see that evidence. Since they do not join chemically, mixtures can be separated without a chemical reaction. And we will look here in a minute at ways to separate mixtures. In other words, you can separate mixtures physically. You can use the properties of the different substances in that blend or that mixture, and you can use those properties of each of the substances to pull them back apart. Since mixtures are blends, mixtures can vary in composition. In other words, you are not required to put a mixture together in any certain proportions. And since you can do that, the mixture can vary in composition throughout. And as a result, your mixture can have differing properties throughout. Because when you make a mixture, the properties of each of the substances in that mixture are maintained. When you have a chemical reaction, when a chemical reaction occurs and you put two things together, and maybe they join to form something else, the new thing they form has properties entirely different than what you put together to make that compound. When you have a mixture, the things retain their properties. They do not change whatsoever. Salt water is an example of a mixture. When you make salt water, you dissolve salt in the water. The salt is still there, the water is still there. You can recover the salt from the water by perhaps evaporating the water off or boiling the water off. The property of water is that it will reach its boiling point at a much, much lower temperature than the salt does. So you're using the properties of the fact that those substances have differing boiling points. That is one way you could take that apart, and that would be a physical change. That is not a chemical change. Dissolving salt in the water, you're just making a salt water mixture. And you can vary the way you make that mixture. You can add a little salt, which would make it slightly salty water, or you could add a lot of salt, making it very salty water. So when you're making a mixture, it is not a requirement as to what proportions you put of each of the substances in there. The water's still water, the salt is still salt. You would need, in the naming of salt water, you would need to indicate in the name that salt is there, so you would call it salt, and you would need to indicate that water is there. You would use water. But writing the formula for salt water, you would write the formula for salt. If it was sodium chloride, you would write NaCl, and you would need another formula separate for water, H2O. When you have a compound, there is only one formula needed for the compound. Sodium chloride is a compound. Its formula is NaCl. Water is another compound. Its formula is H2O. So every compound has its own unique formula. Salt water would have two formulas since it's two substances that you put together. So that are some differences between mixtures and compounds. Looking at mixtures, we can classify mixtures two ways as well. Mixtures can be homogeneous or homogeneous. Mixtures can also be heterogeneous or heterogeneous. And we will talk about different kinds of homogeneous mixtures. We'll mention solutions and alloys, which we discussed last unit in Unit 1. We did not discuss any of the heterogeneous or heterogeneous mixtures, such as mechanical, suspensions, colloids, a word not here, emulsions, but we'll talk about 4 different kinds of heterogeneous mixtures. But as we mentioned, we've already talked about homogeneous mixtures. We did mention these definitely in Unit 1, but it's worth recapping now. Homo means same. So homogeneous or homogeneous mixture is a mixture that is the same throughout. It is uniform in composition. So this is a type of mixture where it'd be the same. If you take a sample of different parts of the mixture, in other words, if I have a glass of salt water, if it's homogeneous, the concentration of salt in one portion of it would be the same as the concentration of salt in the other portion of it. It would be the same throughout, same proportions and compositions in all parts of it. One example of homogeneous mixture is called a solution. We already mentioned a solution. A solution's formed when one thing is dissolved in something else. And you dissolve it, and it is mixed evenly throughout, and it's said to be in the same phase. In order to form a homogeneous mixture, the substances must be soluble in one another. In other words, they must mix very well together, where the one thing is able to dissolve the other thing. The substance that gets dissolved is called the solute. So when we make salt water, the salt is usually pulled apart by the water. The thing that gets dissolved, the salt, would be the solute. The substance that does the dissolving is called the solvent. The solvent is the thing that pulls apart the solute. The solvent is generally the substance that is available in a greater quantity. The solute is available in a lesser or smaller quantity. Another type of homogeneous or homogeneous mixture is called an alloy. Alloys are metals that were melted and mixed with another substance. Very often that other substance is a metal, but it does not have to be a metal. For example, steel is considered to be an alloy where we have iron, the metal, mixed with carbon, a non-metal, and they are melted and put together. Another example of an alloy that we mentioned a lot in Unit 1 was brass when we were dealing with alchemy. Brass is an alloy of copper and zinc, and that's when we were talking about changing the pennies. The alchemists were trying to change ordinary metals, base metals such as copper, into more valuable metals such as silver and gold. And we mentioned that really the demonstration we saw, they produced brass, which looks a lot like gold, but it is really an alloy of copper and zinc. Another alloy involving copper is bronze. Bronze can be made, I believe, with copper and tin, SN, but it can also be made with other metals such as aluminum and nickel. So we've already talked about homogeneous or homogeneous mixtures. We spent a lot of time mentioning those in the last unit. In our next video, we're going to pick up with the type of mixture, another way of categorizing a mixture that we haven't discussed yet, and that's heterogeneous. And stay tuned for our next video.